Hello YouTubers, welcome to the first video in the entrepreneurial software engineering where I get to combine 17 years of experience with entrepreneurship, software engineering, and some skills and mechanisms to find your innovative idea, your genuine idea that could change the world. I personally believe that each and every person out there have the capability and the ability to come up with an idea that'll make everyone else's lives better. It's just about having the right tools and being in the right environment to be able to find that idea and actually take action into it. It's very common that a lot of people come up with really great ideas, but they don't move forward with it. You just let it die. This course is about giving you the tools and the skills, the language of the century, software engineering, that'll help you build products for whatever your passion is, whether your passion is into sports, restaurants, airplanes, whatever your passion is. You need to know how to write software at some point in time in order for you to be able to contribute or engage in your in the field or the passion, whatever you're passionate about. And software engineering is not really that hard. It doesn't really require a lot of knowledge about mathematics. It really requires a lot of knowledge about logic. For instance, let me give you an example. Software engineering, when you're building a software, let's say you have a phone app and you want to add a button, and when you click that button, you want a message to pop up to say hello or hello John, for instance. There is no math there. You're basically hooking up events. You're finding out what code displays a message and what code it triggers when you click the button, and you just hook them up together. Just like the Legos, it's just as simple as that. But then it gets a bit more complex and a bit bigger, but you still don't need a degree in mathematics in order for you to be able to write good software. What I want to talk to you about today specifically is modeling, how to pick up something in the real world and turn it into something inside of your computer, model it into a computer program so you can manipulate it and you can move with it and you can solve problems. Let me give me an example. In this room that I'm sitting in right now, let's say I want the computer to help me find the best way to organize the tables and the TVs and the computers in this room, right? So this is a problem. I have a problem with organizing things in my room, and I want the computer to tell me where to place everything in this room in a way that matches specific conditions. The first thing you want to know about is how to model the components in this room, right? Everything around us, let's say this mouse, for instance. This mouse has so many features and so many variables. It has a color, it has a height, it has a width, it has a weight, it has a price, it has a value. It has so many different variables, but when you're modeling something to solve a problem, you will only focus on the attributes or the features within the object that you're trying to model that has a relationship with your problem, right? So since we are organizing things, let's say if I pick up the table over there or the table behind me, if I want to solve a problem with space, then all I really need to care about is height, width, and length, right? How tall is it, the length, how high, the height, all that kind of stuff. So how do we model things? How do we turn things into something that we can manipulate? If you come out of this video just understanding how to look at something and turn it into code, then you have actually exceeded, you've reached the exact goal and exceeded what I really wanted you to learn today. So you need to have Visual Studio, which is an integrated development environment that we're going to use to build our software. So you're starting here with Visual Studio, and then I'm clicking creating a new project, and then we're going to start with a console app. A console app, an innovative entrepreneurial engineering, let's say one. Right, so I'm just giving a name to my application, right? So it's just you naming your project so you know what this project is doing. You can find it later. Always make sure you give your projects a meaningful name. All right, so we have that. Let's set that right. Okay. So as soon as you start a new project, the first thing you're gonna see is a bunch of stuff on the screen. There's a lot of code in here. It's basically a setup for you to be able to run a program. You'll see here a console right line hello world. If you run that, it'll pop up from the button up above. It'll run that. It'll say hello world, and then the program will exit, right? But that's not what we want to care about today. We want to model things, right? Just heads up, I don't expect you to know anything about programming, but I expect you to be focused and try to get as much as you can from this course. So let's add a new file in here, a new class. A class is the concept of what you're trying to model, right? Class, model, contract, there are so many different names for the same thing, right? This is our model. So let's say table, right? So this table behind me, I want to model this table, right? So if I go here and I want to set up bunch of variables, bunch of attributes that helps me describe the things that I care about when it comes to space for this table, right? So that means I need to add in some numeric value for height, right? I need to add a numeric value for width, and I need to add a numeric value for length. This way, right? So you see how simple it is. I'm adding attributes. These are attributes that describes the things I care about the model that I am trying to about the object in reality that I'm trying to turn into a code, right? The things I care about, the attributes that helps me manipulate the object, right? So what does that mean for us? It means height, width, and length. That means I could use that table model. If I go to my program in here, I get to go and say my table. Here's a name for the table behind me, right? Let's just say call it my table. And then I could create an instance of this table that tells me that I can set up all these variables. Let's say the height is 10 and the length is 25 and the width is I don't know, maybe 15, right? Or maybe 5. So what does that do? Like, what do you do with that? This is, once you were able to model things, to break things down into that means for you that you can manipulate them. You can use them to solve a problem, right? So the problem that we're trying to solve here is, let's say we want to see if a table, if I bought a new table, whether it would fit in my room or not, whether there's a space for it in my room or not, right? So what we need here is another model that represents the room that I'm living in, right? So let's go ahead and create another model. And let's call it room. The room also has a height, very similar attributes. The room has a width, and the room has a length. Right? So that means for me that it'll tell me whether a room, a table will fit into my room or not. So let's create a model for my room. So if I go in here and say var my room, new room, and then I can get set some stuff in my room. Let's say the height of my room is 100. The width in my room is 50. And then the length in my room is, I don't know, maybe 75. Just random variables. So you see, we created a table, we created a room. So I modeled, I extracted an object in the real world, and I pulled it into a component or an object in my computer, and then I'm letting my computer help me decide whether a table fits in or not. Now, of course, you could so easily identify with the naked eye, whether one table could fit or not. But what if we have 5 tables, right? What if we have 20 tables? What if you're trying to bring in 50 tables into a big storage, and you don't know exactly, whether they'll fit in or not? Should we put them on top of each other, or should we, stretch them out? What should we do with that, right? So if you look at the room, assuming that the room is empty, right? Assuming that the room is empty, we could go here and say, if table the height is less than my room the height, so the height is less, so that the table height is smaller than the room height, meaning that it would fit in, right? And then, and this is me saying, and the table width is smaller than the room width, right? So the width would fit in, and the table length is smaller than the room length, right? What would that do? Then print a message that says this table would fit in your room, right? So if we run our program, it would say this table would fit in your room. The table that you've entered would actually fit in your room. What if we want this to be a variable? Like, I want people to be able to come in and enter in the dimensions of their table, and then I print out, whether that table fits in or not. So let's try it in here, and let's take a user input, right? So console dot write line, enter your table dimensions, right? And then we could go and say console. That's us interacting with our user. So we say table height, and then you do console. So the height, so we want to take in the height, input height. That's just a variable name. And then we could go and say console.readline, right? So that we got the height. We want to convert that height into an integer so we can parse it. So we're asking people to enter in heights, and then we're going to repeat that for the rest of the dimensions. So we want height, we want width, and we want length. Let's do that. Width, and we want length. So input width and input length, right? And instead of hard coding these values, we will just set them up in here. So input height, input length, and input width, right? Here's our width. Now everything is dynamic, meaning that, we will let the users tell us, whether what the dimensions are of the table that they're trying to fit in a room, and then we will tell them whether that table fits in or not, right? So enter your table dimensions, table height. It's asking for the height. Let's say my height is 10, the width is 75, and let's say the length is 150. So what's the message in here? It didn't print out the stuff that we okay, so it didn't print out, so we forgot to add in another condition here that says if none of these fit, then we should say the table won't fit in. So let's go and say write line, your table will not fit in this room. So this else condition in here, this is us saying if the table height is not less than the room height, and the table width is not less than the room width, and the table length is not less than the room length, if these conditions are not all fulfilled, then print out your table will not fit in this room. Your table will not fit in this room, right? So let's try that again. It's building up. Let's try that again. All right. So again, so the table height, let's say my height is 25, but the width is 75 and the length is 150. So it says your table will not fit in this room, right? Let's try a different size for a different table, right? Let's say I want to enter in a table. Height is 10, width is 50, and length is 100. Your table will not fit in this room, because the height, the length is small, blah, blah. Okay, let's try something smaller, right? Let's try a height of a 10, a width of 25, and a length of 50. Your table would fit in your room. The table would fit in your room. So you see what I'm trying to do here? I don't want you to focus too much on the code itself more than the concept. If you understand the concept, the code is just, you know, the code is just a way for you to express yourself through the computer, a way to mirror your thoughts. But the code itself is not your thoughts. It's just a way to mirror your thoughts in a way the computer would understand, right? So think about our example in here. What you should do, what you should think about is look around you, look at the objects around you, and try to model that. Try to find a problem that needs to be solved. You know, this problem could be anything. Like the other day, I had this client of mine that came in and said, we want to build an application that helps, you know, tell us how much items left in storage before we order more pet food, right? More dog food, more cat food, and stuff like that. So how do we build that? You know, think about that problem, right? You have a storage, you have a bunch of items, you need to model that stuff, and then every time an item is purchased, you take off one record, right? So if you have 10, you sell an item, it becomes 9, then 8, then 7. The more people come in and buy, and then you start an alert when things don't go, like you have a shortage of item, we're about to run out of items. You know, so think about that. Think about modeling. Think about bringing things from the outside world and bringing them into your machine. You know, how would that look like, right? Think about your computer. Think about your everything around you. People in school, anything. There's a lot of things that we can improve. And engineering, as an innovative engineering, is the idea of looking at things that could benefit as many people as possible and then making it happen, right? Innovation, if you invent something that you don't personally use, it's probably not going to go so far, right? So invent something, build something that is useful to you personally. And that's the very first step into building a good product. That's the very first step into building something that people would be actually interested in. And then the more people are interested in, your product turns into something that's simple, plug and play. People could just pick it up and use it, and it becomes useful to them. Because you'd be surprised, the problems that you're trying to solve for yourself, you're not probably the only person in the world with these problems. So there's a lot of people out there that would be interested. So if you are benefiting from that, it is very likely that a lot of other people would. If you have any questions, comments, or concerns, feel free to drop me a comment in the comment section. Thank you for watching, and I'll see you in the next video. Thank you.